Hello, everyone. My name is Anthony Campolo, and I'm going to be showing you how to do Web3 composability. So this is the Composability Summit. Thank you to Scott and Ishan for the invitation to present here. And I am a representative of the Web3 world coming to you to tell you a little bit about what is Web3, how does it fit into this whole composability thing. So I want to really get across in this talk that Web3 has a lot in common with things like the Jamstack. I know that this isn't a Jamstack conference, but Jamstack to me is a really good example of composability and this idea of having different pieces that we can take and we can easily slot together. To me, that's really the kind of promise of composability, is that we can work with our architecture a little bit like it's just Lego pieces that we're combining together. So you can have a front end, and that front end could be any kind of JavaScript or even non-JavaScript type of thing you want. So it could be different frameworks. It can be SSR, could be client-side rendered. It could be pure static, but then that could be querying some sort of backend. So the backend traditionally has been something like a headless CMS, or maybe just an actual database if you're going full stack Jamstack. But in this talk, we're going to be looking at how does blockchain fit into this, and how does composability work when you're composing a front end with maybe a smart contract. So there's not going to be any slides here. I'm just going to be kind of walking through an actual code demo, because I think that's going to be the easiest way to kind of understand what's going on here. I think when it comes to this talk of like micro front ends and micro back ends, or microservices, sorry, then you get into this world where, you have like a bunch of boxes and lines pointing together with boxes, and it's like, wait, what is actually happening here? So I want to actually show what is it like to actually work with this stuff? What is the code really doing? And what we're going to do is we're going to deploy a smart contract, and then we're going to query that smart contract or read from that smart contract from a React front end. And then we're going to then give us the ability to write to that smart contract. So you can think of it like some basic CRUD functionality: create, read, update, delete. Although you can't delete anything on the blockchain. We're just going to be create, read, update, and then we're going to deploy that to Edgio, everyone's favorite hosting provider. So I'm going to go ahead and share my screen here, and we got that going. Let's minimize that. And I've already got a project set up for us here. So all I've done is just created a basic React app and haven't done anything else. And the first thing we're going to do is we're going to install some dependencies. Now, these dependencies include .env for our environment variables, Hardhat, which is our kind of CLI development environment. That's what's going to give us the ability to deploy the smart contract. Ethers is our client library that lets our front end interact with the smart contract, because when we deploy the contract, there's going to be certain methods that we can read from it, which you can kind of see here in the smart contract that we're going to get into. And then Hardhat Ethers, which is from the creators of Hardhat, and that's just a library to kind of integrate the two together. So when we deploy the contract, we can use some Ethers methods. And then the CLI for layer 0 being where we will deploy this. So let's go ahead and run that, and that's going to install all of our dependencies. We're then going to set up our project structure. So when you create a Hardhat project, you have contracts and then you have scripts. And our contract is going to be written in Solidity. Solidity is the programming language of the blockchain for Ethereum specifically, and then other EVM compatible chains. If you don't know anything about blockchain or any of these words that I'm saying here, that's not super important. But the main thing is that we have a blockchain that we're going to be able to deploy a program to, and that program can do any sort of arbitrary logic that you can think of. And then we're going to have a simple little contract that's going to be hello world. We're then going to have a deployment script. We're then going to have our Hardhat configuration. And then I've already set up our environment variables here, so I'm going to skip this step. But for our environment variables, we have an RPC URL, And that is how we're actually connecting to the blockchain itself. And if you don't know what a blockchain is, I should probably give the blockchain kind of 101 for anyone who hasn't heard it before. Blockchain is like a distributed database that lives on many people's computers all at once. So if you think of like a Postgres database, it's kind of like that. It's not relational, but it's like a way to store data and a way to interact with the data that's stored on it. And the difference is that that database is saved on multiple people's computers all at once, and they're all synced together to have a shared state of the world. And this is useful if you want to have something that we can all connect to, we can all interact with, that is not necessarily owned by any one person or is not tamperable and cannot be changed because it's on multiple different computers. It's decentralized. And so this is why what we're building is called a DApp, a decentralized app, because we're interacting with a decentralized network of computers. So if you want to know more about that, the kind of philosophy and history of the blockchain, there's a ton of material out there. But for this talk, we're going to be more so just looking at like how do you actually do this stuff. So the last thing I did here was adding our .env to our getignore, because this has private information, our RPC URL, and then our private key for our crypto wallet. And we'll look at the crypto wallet in a little bit. So this is our smart contract. And what's happening here is we have a variable, which is just called hello message. And so this is pretty comprehensible if you've ever done any sort of, programming language before where you've worked with objects and constructors. Should be fairly comprehensible here. We have a variable, the hello message, and then we have a constructor that will set the hello message when we deploy the contract. So when we deploy the contract, we're going to feed in a message, and that's what's going to be this variable that's going to be saved in the contract state. We then have two functions. We have a hello function, and the hello function just reads back the hello message. So it's going to have a message that's going to say hello from something, and when you read that message, you trigger the hello function, and then it reads you back that hello message variable. And then since you also said this is going to have, updating functionality and also creating functionality, we have the set hello function. And so the set function is what will allow us to change that message. So when we first deploy it, we're going to pass in a message into the constructor that will set it. But then if we want to change it at any point, we can run the set hello function, and that will allow us to then change that message by setting the message that we pass in to the new hello message variable. So the underscore is anytime we're passing in a new message or passing in the first message to set it, that is the underscore, and then the underscore, whatever we pass into it, will be set to then the canonical variable, which is the hello message variable. So go ahead and save that. Then the other thing we have is our deployment script. Our deployment script will have a Ethers method, which is get contract factory. What this is doing is this is taking our contract, which is hello world.sol, and it is instantiating that contract. So by instantiating the contract, we can then deploy it and pass in a message. So this was the message here that I was talking about setting through the constructor. This will be the message that we will set to that hello message variable. We'll say hello from Composability Summit. Then we actually run that deployed method, which then deploys the contract itself, and we will get some information console logged out, including the contract's address and then the signer's key as well. All right, now we have that. We only have one other file that we will need to actually deploy our contract. And here we have just a couple things in our config. We have the version of Solidity, which we set up here, 0.8.6. We also have where we want the artifacts to go. And what this is something called an application binary interface. And it's a fancy term, but it just means that we're going to generate basically like an API for our smart contract, and that API is going to correspond to these methods, the hello method, the set hello method, and there's going to be basically a big old JSON file that's going to specify exactly what the contract can do and how you can interact with the contract. And when we do that, it's going to take that big JSON blob and it's going to stick it in our project. And so we want it to go into our SRC because that's where our React app is that we generated. And then finally, we have the actual network that we're deploying to. This is because there are multiple different blockchains. When you're doing this, you can do this exact same contract to the Ethereum blockchain if you wanted to. We're going to be doing it to the Avalanche blockchain. Now, if you want to know the difference between Ethereum and Avalanche, is a long rabbit hole to go down, but the most important thing is that Avalanche is a newer, more scalable, more environmentally friendly and faster and cheaper blockchain that basically does exactly what Ethereum does. So that's why I'm a big fan of it and I like building on it. And the way we're going to connect to it is with our QuickNode URL. Just so you know, QuickNode is a deployment blockchain company that I work for. So that is why I will be using that in particular, but there are other ways to do this. There's plenty of other RPC node providers as well. So that is just the way I will be doing it. And then we also have our private key, which is for our wallet in particular. We will be using MetaMask right here. All right. Now, that is our actual contract stuff. And so this is why I say this is all composable, because the contract itself is decoupled from our front end. Now, the front end itself is going to be a React app, but it doesn't have to be a React app. It could be any kind of app that you want. So here we just have a basic React app with a set state, and that's going to be a hello variable, and then a set hello value, basically a setter. And we're going to run the fetch hello function. And what this is going to do is this takes in the basically information for our contract, which includes our API, and then our provider, which is how it knows to connect to MetaMask, which is our specific wallet that we'll be using. And then we run a try catch, which then runs the hello method on the contract, which is what is set here. So that is now a function that we can just call in JavaScript because of our ABI. And then we will set the results of that function to a variable called data, and that will contain the message of our contract, the hello message variable. And then we'll run set hello value to then set that message to the state. And once we've done that, then we can just display it as a variable here in our div. And the way we run it is by running this button, which has an on click, and that runs the fetch hello. So this is kind of your React use state 101. If you've never done React before, then you're probably like, what is happening here? But this is if you have done React, then this should be fairly comprehensible. And the only thing we need to do here is insert our actual contract address, which we don't have yet because we have not deployed our contract yet. Now, to deploy our contract, we're going to run this yarn hard hat compile. That's going to take the contract, create all of our important bits and pieces, application binary interface. We now have this here. If we want to see what I've been talking about this whole time, this ABI, this is the ABI. So this is our big old JSON blob that has things like hello and set hello. But this is not yet an actual contract on the blockchain yet because we have not deployed it to the chain. Now, we do that by running the deploy script and then telling it what network we want to deploy to specifically. So Fuji is the Avalanche test net. And the reason why we're using a test net is because we want to be able to create this project and interact with it without having to pay any money. Because if you're actually doing this on Ethereum mainnet or Avalanche mainnet, then every time you run the setter, every time you set the hello message, that is going to say, hey, you need to pay a little bit of gas fee to do this. That's because computers aren't free. So you can't use the network necessarily for free unless you're using the test net. The test net you can do whatever you want with, and you don't have to pay anything. So we're going to run this, and then it's going to console log us out this contract here. And then if we want to see that this contract is actually live, we can check it out here on the Avalanche snow trace. So this is like a ether scan if you've ever done this before. So we can actually see our contract. We can see it living on the blockchain itself. We can see it was deployed 36 seconds ago, and we can see my wallet address there that deployed it. So it is there, it is live, and we can now interact with it in our React app by including it right here in our contract address. Now that we've done all that, we can kick open our development server, and here we will see this, and it will let us actually see the message by clicking, and then hello from Composability Summit. So that was the message that we fed it in here in our deployment script, which then set it to the hello message variable, which then we read out in our set state by running the contract hello and then feeding it out into our actual component here. So that's all cool, but you're thinking, wait, how do I write to it though? And that is where our set hello function comes in. So the set hello function we'll put right here under our fetch hello. And it's very similar to the other function we created. The only difference being that we're also including now the signer, because when we change the message, we have to sign it with our wallet. That way, every time it's changed, there's a history and there's a ledger that basically says, hey, this was changed from this to this, and it was done by this person's wallet. And then we will run set hello method on the contract and give it the current hello variable. And then the way we actually feed that into the React app is with an input and a button. So the input will give us a target, which will set the value to the event, and then it'll set that to the hello value. And it will be triggered by this button, which has an on-click for the set hello function. So now we got all of that. Let's go back here. So now we see all of that. And if we actually open up our developer tools, we can see here that every time we click the button or change it, it's going to give us this message, which lets us know that we're setting the variable to this message, and then also will give us the contract address as well. So let's change this to hello from JC Web Dev, because that's me. And then it's going to say, hey, you need to confirm this transaction and you need to sign it. So we're going to confirm it, and now we will sit and wait patiently as this goes through, because the one thing that you need to know about blockchain is that because it is a huge distributed network of multiple computers talking to each other simultaneously, that means that they have to agree on the state, and that requires a little bit of time. So always be patient when working with blockchains. But now we see here, we got our new message. So if we refresh the page and click again, then we get this new message. All right, so that's pretty exciting. But right now, we just have a project living on our computer. We don't have an actual website yet or a DApp. So the way we do that is with this sweet layer 0 init command. What this is going to do is this is going to allow us to configure our project to run on layer 0's servers, or Edgeo. And now we have this, so we need to give it a website. I'm going to set it to one that I've already been using here, and that is going to configure our project to work with their platform. Now we're going to grab this chunk of code here to configure the router, and this is because we are using a basically single page application setup, so we just need to let it know where it needs to spit out the actual project and where to read it from. So we're telling it to basically take a look at our index.html file. And then we're going to run our yarn build, and this is going to build our whole project into a static bundle, and then we will be able to deploy this bundle to layer 0's servers. And then once we have done that, then we'll have the exact same project, but instead of on our local host, it will be living on an actual URL that others can visit and they can interact with. So anyone who has a MetaMask wallet or a configure for Avalanche could also interact with this contract and change the message if they are so inclined. So after you watch this message, you can go check out the contract yourself and play around with it. All right. Let's close out some windows here. All right, great. So this should be good to go now. Let's open it up. And here is our project. We see the last message that we set, hello from AJC Web Dev. Let's say hello from Edgio. And it will ask us again to confirm this transaction. So we'll go ahead and confirm, and then this will, in due time, give us the new message. And then that will be the entire demo. So hopefully this gives you a bit of an idea of what we mean when we say Web3 is Jamstack by default or Web3 is composable, because as you see here, we have this contract, and the contract is completely decoupled from our front end. We can interact with this contract however we want. If you wanted to just send straight RPC methods to it to get this message back, you could do that. You could do that from curl. You could do it from lots of different libraries. I just used Ethers.js because it's one that I'm familiar with. But you could do it with a Ruby library if you wanted to. You could do it in any programming language you can possibly think of. So this is really the composability dream here, because we want to have all of our pieces of our application separated. We want to have our concerns separated. And this gives us the ability to have a contract that has all of the functionality. It has the API methods. It has the data living on it. But then we also have a front-end client that can connect to it, and your front-end client can be however you want to set that up. So thank you so much for watching my presentation. Really appreciate it. And if you want to learn more, check out quicknode.com. If you want to get in contact with me, I'm AJC Web Dev on Twitter and GitHub and pretty much anywhere on the internet. And we do a lot of content like this. If this is something you found interesting, you want to learn more, you can check out Quicknode HQ on Twitch, where I do regular live streams to walk through stuff like this, and also bring on guests. And I'm sure we'll have some, Edgio folks on soon to learn a little bit about how to make this platform really work well for Web3. So yeah, thank you so much for watching, and hope to see you soon.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We'd love to hear from everybody. And there's always so much value and good conversation going on there. We wanted you to be a part of it too. So come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it now. Follow us. All right, see you soon.